Glycolysis, from glycose, an older term for glucose plus lysis degradation, is the metabolic pathway that converts glucose C6H12O6 into pyruvate, CH3COCOO- plus H+. The free energy released in this process is used to form the high-energy molecules ATP, adenosine triphosphate, and NAD, reduced nicotinamide adenine dinucleotide. Glycolysis is a determined sequence of 10 enzyme-catalyzed reactions. The intermediates provide entry points to glycolysis. For example, most monosaccharides, such as fructose and galactose, can be converted to one of these intermediates. The intermediates may also be directly useful. For example, the intermediate dihydroxyacetone phosphate (TAP) is a source of the glycerol that combines with fatty acids to form fat. Glycolysis is an oxygen-independent metabolic pathway, meaning that it does not use molecular oxygen, that is atmospheric oxygen, for any of its reactions. However, the products of glycolysis, pyruvate and NAD plus H+, are sometimes metabolized using atmospheric oxygen. When molecular oxygen is used for the metabolism of the products of glycolysis, the process is usually referred to as aerobic, whereas if no oxygen is used, the process is said to be anaerobic. Thus, glycolysis occurs, with variations, in nearly all organisms, both aerobic and anaerobic. The wide occurrence of glycolysis indicates that it is one of the most ancient metabolic pathways. Indeed, the reactions that constitute glycolysis and its parallel pathway, the pentose phosphate pathway, occur metal-catalyzed under the oxygen-free conditions of the Archean oceans, also in the absence of enzymes. Glycolysis could thus have originated from chemical constraints of the prebiotic world. Glycolysis occurs in most organisms in the cytosol of the cell. The most common type of glycolysis is the Embden-Meyerhof-Parnas (EMP) pathway, which was discovered by Gustav Embden, Otto Meyerhof, and Jakub Karol Parnas. Glycolysis also refers to other pathways, such as the Embden-Dauterhoff pathway and various heterofermentative and homofermentative pathways. However, the discussion here will be limited to the Embden-Meyerhof-Parnas pathway.